Good morning. Today we are going to discuss schedules and recoverability. Schedule or history. Schedule means order of execution of operations from all transactions. Operations from different transactions can be interleaved in the schedule. For example, in a transaction you can have many read and write instructions, and in some other transaction also you have a number of read as well as write instructions. So interleaving this, that means executing one transaction after the other is serial. It's a serial schedule. That means suppose that you have two transactions T1 and T2, then after completing T1 you are doing T2, or after completing T2 you are going to have T1. But that is not practical. That means concurrency, if there is no concurrency or interleaving of operations, it will be very time consuming. Okay, so in that case operation from different transactions can be interleaved in the schedule. Total ordering of operation in a schedule. Finally, for any two operations in the schedule, one must occur before the other. Suppose that two conflicting operations in a schedule. Two operations in a schedule are said to be conflicting if those operations belong to different transactions. That means, suppose that you have two transactions T1 and T2, then two operations are said to be conflicting if both of them belongs to different transactions. One belongs to T1 and the other belongs to T2. Okay, then these two operations access the same data item X. Operation access the same data item X, and at least one of the operations is a write item. That means three conditions has to be satisfied if two operations are said to be conflicting in a schedule. Suppose that you have two transactions T1 and T2, then those operations are said to be conflicting if those operations belong to different transactions, and they should access the same variable X, and at least one of them should be a write item X. Two operations conflict if changing their order results in a different outcome. If changing their order results in a different outcome. For example, read-write conflict and write-write conflict are there. See, now characterizing schedules based on recoverability. Recoverable schedules. Recovery is possible. Recoverable schedule means recovery is possible. That means suppose that your system, or if there is a system crash, or there is a loss of data, or something extraordinary happens, then you have to recover those data. That means if you have recoverable schedules, recovery is possible. Non-recoverable schedules should not be permitted by the DBMS. No committed transaction ever needs to be rolled back. No committed transaction. Suppose that you have a committed transaction, then there is no need to roll back it. Cascading rollback may occur in some recoverable schedules. Uncommitted transaction may need to be rolled back. That means cascading rollback is one of the techniques using that we can recover data. That is using cascading rollback. For that we are using system logs. Okay. Then cascadeless schedules. Cascadeless schedule means avoid cascading rollback. Strict schedule means transaction can neither read nor write an item X until the last transaction that wrote X as committed or aborted. Okay, that means suppose that if a transaction is having a write item X, that should be committed. Unless it is committed, no other transaction can read or write that data item. That is strict schedule. That means if you have a strict schedule, then your recovery process is simpler. Restore the before image, that's all. Characterizing schedules based on serializability. Serializable schedules, always considered to be correct when concurrent transactions are executing, places simultaneous transaction in series. For example, transaction T1 before T2 or T2 before T1. That means there is no concurrency or interleaving of operations. Then see here, figure A shows a serial schedule. That means all the operations of T1 is executed, and after that all the operations of T2 is executed. T1 followed by T2, and in the second transaction initially you are going to do T2 and then you are going to do T1. That means T1 followed by T2. And in example schedule C, you have interleaving of T1 and T2 operations. Interleaving of T1 and T2 operations. In schedule D also you have interleaving of T1 and T2. Okay. Now, characterizing schedule based on serializability. Problem with serial schedules. Limit concurrency by prohibiting interleaving of operation. That means if you have a serial schedule, for example T1 followed by T2 or T2 followed by T1, there is no concurrency and it is prohibiting interleaving of operations. It is unacceptable in practice. The solution for this is determine which schedules are equivalent to serial schedule and allow those to occur. That means to what extent you can have interleaving of operations. That means you can have a schedule which is equivalent to a serial schedule. Serializable schedule of n transaction. Serializable schedule means if you have a set of operations, read and write operations in a schedule, and if you have two transactions having a number of operations, and that is serializable, that in the sense interleaving of operations are permitted if that is equivalent to a serial schedule, equivalent to some serial schedule of same n transactions. Result equivalent schedules produce same final state of the database, may be accidental. For example, cannot be used alone to define equivalence of schedule. For example, suppose that you have two schedules S1 and S2. If you do S1 followed by S2 or S2 followed by S1, if the value of initial value of x is 100, then it will give the same result, because x is equal to x plus 100 means 100 plus 10 is 110. Initially x is equal to x into 1.1 means 100 into 1.1 again is 110. Okay, so both of them results in same result. That means they are result equivalent. Cannot be used alone to define equivalence of schedules. This cannot be used alone to define equivalence of schedules. Now, conflict equivalence. Relative order of any two conflicting operations is same in both schedules. Relative order of any two conflicting operations is same in both schedules. Relative order. Serializable schedules. A schedule S is serializable if it is conflict equivalent to some serial schedule S dash. Conflict equivalence means relative order of any two conflicting operations is same in both schedules. Serializable schedule means schedule S is serializable if it is conflict equivalent to some serial schedule S dash. See, for example, testing for serializability of schedules. For each transaction Ti participating in schedule S, create a node labeled Ti in the preceding graph. For example, you have in our example we have in all the four cases you have two transactions T1 and T2. Then you have to have two nodes T1 and T2. That means Ti and Tj. Okay. Then for each case, I'll show you. This is an example. That means all the four cases are discussed here. That means for each transaction you should have a node for each transaction. Each transaction is represented by a node. Then For each case S where Tj executes a read item after, that means if read and read it is not conflicting, but read and write and write and read, write and write, that means two operations are said to be conflicting if those two belong to two different transactions and they are accessing the same data item, and third condition is one of them should be right. And for each case S where Tj executes read item X after Ti executes write item, that means initially Ti has to be executed, that means Ti to Tj, that means Ti arrow to Tj, Ti to Tj means only after Ti you can proceed to Tj. And write and read, that means if you have read and write, write and read, or write and write, that means you should have an arrow from Ti to Tj, means Ti has to execute before Tj, that is the meaning. So after writing, after doing this, if this is having cycles, then in this precedence graph, if you have cycles, then that is not serializable. If S is serializable if the precedence graph has no cycles. So I will show you here. For A and B, T1 followed by T2. So all the instructions of T2 is coming after T1. That means you have an arrow from T1 to T2. That is regarding A. In B, all the transactions of all the statements of operations of T1 is coming after T2. Then there is an arrow from T2 to T1. Okay, that I will show you. That means here you have in A you have T1 to T2 and B you have T2 to T1. Then we are going to discuss C. In T1 you have a read item X and in T2 you have a write item X. In T1 you have a read item X and in T2 you have a write item X. Then you should have an arrow from T1 to T2. In T2 you have a read item X and in T1 you have a write item X. So in that case those two operations are also conflicting. So in that case you should have an arrow from T2 to T1. So T1 to T2 you have an arrow and T2 to T1 another arrow. That means that forms a cycle. That is the case of C. So in that case it forms a cycle and that is not a serializable schedule. But the last one, that means in both T1 and T2 you have, in T1 you have read item X and in T2 you have write item X. Then there is an arrow from T1 to T2. But in T1 you have write item X and in T2 you have write item X, then again T1 to T2, and in T2 you have read item X and in T1 you don't have write item X. So write item X is there, but the serially it is coming one after the other. So there is a read and write and write and write, read and write. That means T1, there is an arrow from T1 to T2, T1 to T2. So in that case there are no cycles, T1 to T2 only. So constructing the precedence graph for schedules A to D from figure 25 to test for conflict serializability. Precedence graph for serial schedule A, precedence graph for serial schedule B, C and D. So among this, C is not serializable because in the precedence graph you have cycles. Okay. Then how serializability is used for concurrency control. Being serializable is different from being serial. Serializable schedules and serial schedules are different. Serializable schedules are equivalent to some serial schedule. Okay. Serializable schedule gives benefit of concurrent execution. In a serializable schedule, we are promoting concurrency as well as interleaving of operations, and difficult to test for serializability serializability in practice. Factors such as system load, time of transaction submission, priority, process priority affect ordering of operations, DBMS enforces protocol, set of rules to ensure serializability. View equivalence and view serializability. View equivalence of two schedules. As long as each read operation of a transaction reads the result of same write operation in both schedules, write operations of each transaction must produce same results. Okay, read operations is said to be same. See the same view in both schedules. View serializable schedule means view equivalent to a serial schedule.